Alright, the first two examples I did were very simple, and in particular they were simple because in the vertex form f of x equals a times x minus h squared plus k, the a was 1. And that makes everything a lot simpler. Now, in fact, you won't always see something as simple as a being 1, so now I'm going to do an example where a isn't 1. So let's convert the function f of x equals 3x squared minus 6x plus 9 into vertex form. So the first thing I want you to notice is that a now equals 3. All right, this is our ax squared plus bx plus c, and this a here, 3, is going to be the same as this a here when we convert to vertex form. So I want to make a point. There are lots of ways to convert to vertex form, to complete the square. I'm going to show you one. If you know a different way, that's fine. However, I want you to make this deal with me. If you can't do it your way, go back and learn this way, because I guarantee you the chance of making errors is smaller when you do the way I show you. So the first thing I want you to do, and actually let me get a little bit more space here on the board. Okay, the first thing I want you to do is take your f of x equals 3x squared minus 6x plus 9, and I want you to factor out that leading coefficient from all three terms. So the 3 comes out, and this first term is just x squared. When I take the 3 out of negative 6, I get negative 2. So this negative 6x becomes a negative 2x. And finally, when I take the 3 out of the 9, I get plus 3. So the first thing I want you to do is factor out the leading coefficient. Let me write that down because it's that important. Factor out the leading coefficient. Now, take a look at what's going on inside these parentheses. Isn't this just a nice simple quadratic function where the leading coefficient is 1? So what I want you to do is complete the square on this inside portion and just carry the 3 along for the ride. And here's how I would like you to do this. Go ahead and set up your workspace a little bit and remind yourself that you're carrying this 3 along for the ride by going ahead and putting a couple of these extra terms or extra preparation lines down there. So this x squared minus 2x plus 3, that's all inside the parentheses. I've turned them to brackets, but that's just for clarity. So now, complete the square on this portion. Well, I take negative 2 and I take half of that. So over here in a little bit of side work, negative 2, I want half of that. That's negative 1. And negative 1 I square it gives me positive 1. So that means inside these parentheses, I'm going to take x squared minus 2x plus 1, and of course subtract that 1 right back out. And I'm not going to forget to add this positive 3. Well, if I'm just completing the square on the inside, the next step is to recognize that that's a perfect square. That's x minus 1 quantity squared, where the minus 1 came from here. And when I combine these two, I have a positive 2. And now I'm almost done. I've successfully completed the square on the inside. You already know how to do that. You've practiced that. The last step is to take this 3, which notice is multiplied by everything, and just multiply it back through. 3 times the first term gives me 3 times x minus 1 squared, and 3 times the second term gives me a plus 6. So now I've successfully written my quadratic function in vertex form. So let's check and make sure that we did this correctly. If I've written it correctly, then f of x equals 3 times a quantity x minus 1 squared plus 6 should be the exact same with what I started, which remember was 3x squared minus 6x plus 9. So let's just figure that out. Let's multiply this thing out. Well, the first thing is to square out the x minus 1 squared, which is x squared minus 2x plus 1. And then, of course, I have this plus 6 here. Now I multiply that 3 through, and I get 3x squared minus 3 times 2 is minus 6x, and 3 times 1 is a positive 3 with this plus 6. Add up these like terms, and I get 3x squared minus 6x plus 9, which is exactly what I wanted to get. So here's actually another comment. Always, of course, assuming you have time, multiply things back out. And maybe I should be more precise than things. Always multiply your answer out to check. If you've completed the square or converted to vertex form correctly, then if you multiply it back out, you should get exactly what you started with. So in the next video, I'll do another one of these, but you might want to go back through, work this problem on your own, and then check your answer, not just your final answer against this, but check your steps as well against the video.